Okay, sorry about that. The last video shut off, so hopefully I can get this completed on this one. So, our B sub n we found to be 2 over n to the 1/2 power. And that B sub n that we found, that is a p-series. And we know, given what we know about p-series, that that p-series is going to be a divergent one. Okay, so once we have our B sub n, we're going to use the limit comparison test. So we're going to take the limit as n goes to infinity of a sub n, which is 2n squared plus 3n over the square root of 5 plus n to the 5th power. And we're going to divide that by b sub n. So dividing by b sub n is the same thing as multiplying by the reciprocal of b sub n. So that's going to be n to the 1/2 power over 2. And then whenever I multiply, we're going to get the limit as n goes to infinity of 2n to the 5/2 power plus 3n to the 3/2 power over 2 times the square root of 5 plus n raised to the 5th power. Now, if we're taking the limit as n goes to infinity of that quotient, we're only concerned with the n behavior, so we're going to look at the highest degree term in the numerator and denominator. So the highest degree term up top is 2n to the 5/2 power. The highest degree term on bottom is going to be 2 times the square root of n to the 5th power, which is n to the 5/2 power, and the limit as n goes to infinity of that is 1, which is a positive finite number, which is what we want. So we can go ahead and write up our justification now. So since the series B sub n diverges, so again, B sub n is 2 over n to the 1/2 power. So since that diverges by the p-series test, then our given series, which is the sum from n is equal to 1 to infinity of 2n squared plus 3n over the square root of 5 plus n to the 5th power, diverges by, and then we're going to abbreviate the limit comparison test with LCT. Okay, so in some ways, it's similar to the comparison test, and honestly, in a lot of instances, the comparison test and the limit comparison test are interchangeable. So if you can use one, you can use the other in a lot of instances. And like the conditions to utilize it are similar. Both a sub n and b sub n have to have terms that are greater than or equal to 0. And then you have an a sub n and a b sub n that you are comparing. Okay, so I'm going to have you guys do number 2. So go ahead and pause the video to do that, and then I'll come back on the mic to work this one out. Just to let you guys know, when I work this one out, in this particular example, I'm going to have the given series, this series, be my b sub n, and the series that I compare, the a sub n. Okay, and it doesn't matter, you know, how, like which series you pick to be your a sub n, which one you pick to be your b sub n. Okay. All right, so let's take a look at this. I'm going to have this given series be my b sub n. It's going to have every single term in this series b sub n is going to be greater than or equal to 0. So what I'm going to do to figure out my a sub n is figure out, hey, what's going to be the n behavior of this formula that's given. And the n behavior of the formula that's given is going to be dictated by 1 over 3 raised to the n power, which is a geometric series. And we know that that geometric series is going to be a convergent one. Okay, so what I'm going to do then is I'm going to take the limit as n goes to infinity of a sub n which is 1 over 3 raised to the n power, divided by b sub n. So when I divide by b sub n, same thing as multiplying the reciprocal of b sub n, which is going to be 3 to the n power minus n over 1. Okay. So to do that, we're going to get the limit as n goes to infinity of 3 to the n power minus n over 3 to the n power. And then to take this limit, I'm going to separate the numerator into two fractions. So we're going to get 3 to the n power over 3 to the n power minus n over 3 to the n power. So this is going to become the limit as n goes to infinity. 3 to the n power divided by 3 to the n power is 1 minus n over 3 to the n power. If you want to use L'Hopital's rule to evaluate the limit of the second fraction, that's fine. You should be able to look at that and know that the denominator 3 to the n power grows faster than the numerator does. So the value when we take the limit of that fraction is going to wind up becoming 0. So this winds up making the value of that limit 1, okay, which is finite and positive. Okay, so we're just going to write up our justification then. So since the series a sub n converges by the geometric series test, then our given series, which is the sum from 1 to infinity of 1 over 3 to the n power minus n, also converges by the limit comparison test. Okay, so those are your two new tests, the comparison test and the limit comparison test. And we'll work through the next test in our grouping, which is the alternating series test in class next time. All right, have a great day, guys.